Okay. All right. So now this is our new IPR at decreased reservoir pressure. Let's say I want to color it green. Okay. All right. So this is our production target. So let's say production target maybe the reservoir pressure, maybe it's even lower. Okay, so let's say 5,500. So yeah, we do this manual calculation. This one set value to this one by changing LF. So this is our new IPR. And what happened here? Okay, interesting. So now at this reservoir pressure, we get the new IPR, and then we check the intersection to the VLP. We still get production rate of, yeah, 15,000. So maybe the reservoir pressure has been reduced down to 5,200 maybe. Yeah, it's a thought experiment. It's a thought experiment because we just predict that we will do workover after 5 years. Actually, the most proper way is in that 5 years after now, after today, 10 years after today, we need to we need to do the well testing again. We need to measure the reservoir pressure again. Okay, so it's just a thought experiment. This one, changing to this one by changing the absolute open flow. Okay, so now the absolute open flow is 13,900. Check the VLP. Okay. All right. So now check the intersection between the IPR and then the VLP. So more or less here, the intersection between the new IPR and the VLP, the green VLP, is the VLP with tubing of 2.441. We can get production rate of 13,900. So it's more or less 5% increase from the original operating rate. So let's say the original operating rate is 13,000, and now after 10 years we want to get production increase 5% higher. More or less we target production increase of 13,700. And now as the reservoir pressure has been decreased, we can still get operating rate of 13,900. So it's already quite close with our production target. All right, so again, so if you think that after 10 years, your tubing will be broken, your tubing will be damaged, the production rate will be decreased, and you still want to get production rate increase, let's say for 5%, and you get the VLP, the best thing you need to do is you need to do well testing again, and you need to do static pressure measurement again. And from that, you will construct the new IPR. And let's say with our thought experiment, after 10 years, the reservoir pressure has been reduced to 5,200, and we generate new IPR, this blue IPR. And then from the blue IPR, we check the intersection with our VLP. And let's say the intersection between the new IPR with the green VLP, the green tubing performance curve, the intersection is this one here. So the intersection gives me let's check the value around 13,900. Okay, which is very close with my production rate increase target. Okay, so the justification is this. We let's say we predict that the reservoir pressure has been decreased down to around 5,000, and then we construct new IPR, the future IPR, and then we do the intersection between the VLP and the new IPR, and we get that with tubing of 2.441, I can get production increase or production rate of almost 13,900 MSCFD, 1,000 standard cubic feet per day. So that's our justification for the selection of the tubing size, right? So I hope the explanation is clear. Again, if you predict the future, you need to construct the new well testing at that condition. Yeah, you need to predict the reservoir pressure, and you can assume that the A and B of this equation are maintained, so that you can calculate the absolute open flow, and you can construct the new IPR and then intersect with your VLP. All right, so I hope that's clear. Thank you so much and see you again.